So yeah, we're going over smart relays, and we're going to basically talk about how useful they are for small automation projects, how they can basically save you money and time where you don't need as many actual relays, you don't need a load of timers, you don't need to do any funny circuitry. You can just pop in a smart relay and do some pretty decent automation tasks with them, really. You don't need to go full, like the whole hog with a PLC. You can get away with a smart relay. There's barely any setup to get them working. So if you don't know a lot about PLCs, then they're a great place to start, because you don't need to know all the setup. You don't need to mess around with tons of different stuff to get it working. It almost works out of the box. You just need to put a program in them. So yeah, smart relays are great. Has anyone used any smart relays? Welcome in, everyone. Welcome in. So yeah, this program, basically, it took me literally about 10 seconds to put this together. So the output will go on if input 1 comes on, or if input 3 comes on. But if input 2 comes on at any point, then input 1 doesn't work anymore. But input 3 still will. So this could be like, I don't know, not quite an emergency stop button, but maybe some sort of stop button where it will stop you starting the process if that's on. But then you've got an override down here. So it doesn't matter whether I2 is on or off. You can still turn the output on. No smart relays in our plant, but I've used them before. They're great. Yeah, they are, Jeremy. I agree. They're a great starting point if you want to get into PLC programming, if you want to get into the programming side of controls. They're not really difficult to get your head around. You can use a lot of discrete logic to get them working. So when I say discrete logic, I mean you can put in AND gates, NAND gates, NOR gates, NOT gates, OR gates. You know, you can build the logic however you want, but also at the same time, there's a ton of inbuilt functions. So let's take a look. Well, there's a truth table one here. So this is called a Boolean, and I can basically build my own truth table based on, well, I need to put the inputs in first, so let me just do that. So I can build the exact same thing that I just had there, but rather than putting in all these discrete gates and that sort of stuff, I can just do a truth table. So I had it so that if input 1, just let me double check that is input 1, yeah. If input 1's on,
here we go. Money talk.
This logical controls, appreciate the heart me, thank you. What's LV switchgear? LV switchgear is circuit breakers, switchboards, contactors, any sort of switching components, really. So most of the time when I'm talking about LV switchgear, I'm talking about switchboards, loads of circuit breakers, maybe a big ACB incomer, loads of MCCB outgoers, and that sort of thing. So anyway, to go back, so if all the inputs are off, the output's off. If input 1 is on, but input 2 is off, then we put a 1 in there. If input 2 is on at any point, then we want zeros. But if input 3 was on at any point, then basically input 3 turned everything on. So I can put that in simulation mode, run that, and it should give us the exact same logic as what we just had. So if input 1 comes on, output goes on. But if input 2 comes on, the output goes off. And if input 2 is just on, nothing changes. But even if 2's on and you put 3 on, it still comes on. So the excuse me, the logic is exactly the same, but just this time I'm using one block rather than the discrete blocks that I was using. Let me just put them back in. So it was an AND gate, a NOT gate, and there was an OR gate as well. That went to there. Oh, if I can get it in. And I'll use different inputs this time just so we can see the logic is exactly the same, but you're able to do it in a more readable way, easier to sort of understand what's going on, I would say. That went in there. Let me pull that down. So that was our input 1, that was our input 2, and that was our input 3, and that went to an output, which turns on that. So both of these, this logic here and this logic here, are both identical. They do exactly the same thing. There's nothing different about them. So if I turn that one on, output goes on. But if 7 comes on, it goes off. And then regardless of whether 7's on or off, if 8 comes on, the output comes on. So you can see I'll do the same again. Top one, input comes on. If the second one comes on, input goes off. So it doesn't matter what input 1's doing anymore. But if input 3 comes on, the output always comes on, regardless of what 2's doing. Are these used in high voltage power industry? No, I would say probably not HV stuff. No, a lot of HV has their own bespoke controllers and that sort of thing. And for like the automation of HV, you would probably you wouldn't use a smart relay. You wouldn't. No, you wouldn't. So this is more for smaller automation tasks. I have seen these put in switchboards though. I've seen manufacturers take all the basically all the auxiliary contacts off the circuit breakers all back to a smart relay. In fact, it was a Schneider Zelio, and then they fit a Modbus module on the end of that Zelio so that the site BMS system can pull the data out and know exactly what position the circuit breakers are in, or if they have a trip or something like that. You need to play Turing Complete again. I've never played it, mate. I've never played it. I am aware of it though. Yeah. So, yeah, that was just a bit of an example how you can do the same thing in multiple ways, and I guess it's just down to preference. If you like putting in discrete logic gates like this, AND gates, OR gates, NOT gates, that sort of thing, you can do that. Excuse me. You can do that. But if you want to make a truth table and just have all the logic in a table here, you can also do that. You can also decide output on if result is true. Oh, you can basically invert the truth table as well with this one. But there's loads of functions. There's loads of different ones. You can do some calculations and stuff. So you can do some times in, some dividing. I think there is an add and minus one as well. You can do some basic math. What else? So these have a display on them, these smart relays, and I might be able to bring that up. Front panel. So they do have a display on them, and you can actually change it. So at the minute, what this is showing is basically the inputs at the top. It's telling you it's in run. It's telling you the date and time, and it's also telling you the outputs. But you can configure this to make it whatever, you know, you can show alarms, you can show different statuses or something like that on this little screen. So that's pretty good. Right, there we go. Appreciate the follows, guys. Thank you. Capping Nips, I think. Thank you for the follow.
Thanks for the follow.
Dilip, thank you for the follow. I missed some earlier on. Pushkin, thank you for the follow.
Thanks for the follow.
That might be it. That might be it.
Thanks for the follow.
What is the purpose of BO10?
Here comes the money.
Where are we looking, mate? Where are we looking? Oh, BO10, this one here. So, wait, Ahmad, thank you. I appreciate that, mate.
Here comes the money.
It's logical controls. Thank you. I appreciate it. Thank you, guys. Yeah, so the purpose of 10 is I was just showing you how this bit of logic here can be simplified totally with this. So this is a truth table gate, truth table function block, I guess. And the logic that you're seeing here, I've put exactly in here. Appreciate it, Arnold. Thank you. Really, really appreciate it. Thank you. So it's basically just a simplifying block. You know, you could chuck these everywhere if you wanted, and you could do all your logic in a table format. So just doing it that way, where you're turning bits on and off.
Here we go. Money
Delete, thank you for the rose. Appreciate it, mate. Try MATLAB. I've used MATLAB maybe once or twice when I was at university, but a long time ago, mate. Yeah. Or MATLAB, is that what you're saying? I'm assuming you mean MATLAB. But yeah, it's different. MATLAB's like a simulation software, isn't it? No, mate. This is Zelio Soft 2, which is Schneider Electric's smart relay software. What are some examples where this would be used? you could use this. So I've personally used this on fuel control panels. So when you have two tanks and you need to fill the smaller tank with a bigger tank, I've done all my logic inside a smart relay. I have used it on a agitator control panel. So there was a big tank that had a big paddle in it, and it cleaned out the tank. It allowed hot water and cold water to flush it.
Thanks for the follow.
You can use it for basically any task. Small task, that is. Nothing too complicated. Like, they're great, but they're not a PLC. They're a smart relay. I haven't used Logix Pro, mate. No, I haven't fractured keys. It's like that logic gates and stuff we use in aerospace. Yeah, this is just logic gates. That's all it is. It's a smart relay. So you're just putting in basic logic to be able to automate a task or that sort of thing. Wouldn't it be easy to write in a microcontroller? So this, you wouldn't use a microcontroller in an industrial setting. So this smart relay has been tested and designed to withstand harsh environments, electrically noisy environments. It's designed to work at 24 volt DC. You can get 230 volt ones and that sort of thing, and 110 AC ones. But it's an industrial component, whereas you wouldn't do that with a microcontroller.
Thanks for the
software's
follow.
called ZelioSoft 2. It can do ladder logic as well. This is function block diagram, but it can do ladder logic. Right, so, yeah. It also has a PID in it. So you don't really have to do anything too crazy to set up us. It's a basic PID. It's not going to be the most smooth, control system in the world, but it can do it. It can do a basic PID. I don't think you can simulate it, so I won't be able to show it. But it doesn't take very much to set it up. You can set up like one specifically for temperature, or you can or pressure. You can do it manually for anything really, a level or something that you want to control. You put your set point value in, so you can't. This isn't a dynamic set point. This is a fixed set point that it'll always try and achieve. These smart relays can have analog outputs, so it can be like a 4 to 20 milliamp, or it can be a 0 to 10 volt. You do need an expansion unit for that though. Also, if you've got a transistor one, you can do it through PWM. You can have a forward or reverse action. And you can set up your P, your I, and your D settings here. So for something that costs like, £150 or something, they're not crazy expensive. You can do quite a lot of tasks with it, small automation tasks. Yeah, they're pretty good. Search MATLAB Simulink. It's very good. Yeah, but the thing with MATLAB is it's not designed for programming industrial control systems. It's like for, Simulink might be. I can't really remember. I do sort of vaguely remember Simulink. You do PIDs and stuff in it. Thought you had been really expect to see Christmas. No, no, we got rid of the Christmas decorations not long ago though, I'd say. We were a bit late putting them back down. Yeah. Happy New Year, brother. How are you tonight? So, yeah. This is designed for small automation tasks in like industrial settings. So you wouldn't use like a microcontroller or a Raspberry Pi or something. Timers and that sort of thing, you get those. So I could put a timer on the end of this.
Thanks for the
follow. So it doesn't directly drive the output. It could be after a time delay. Let's set this up. So I normally set it in seconds. And say after 3 seconds, that's when the output will come on. Put it back into simulate. Run it. If I turn my output on, you see it doesn't directly come on straight away. It waits for this 3 seconds and then it comes on. And in fact, I'm going to change that symbol just so it looks, I don't know. Let's say we're driving a motor or something. If I go back into simulate now, put that on, you'll see like a little red spinning circle. Looks like a logo. It's similar to a logo. Yeah, it's similar. This is Schneider's version of a logo. Personally, I would say a logo is a better option because it has Ethernet. And you don't need like a special cable to program or anything. But I do prefer the look of the software of the
Thanks
Schneider
for the
one.
follow.
I think the Siemens one looks a bit old, looks a bit dated. Doesn't look very good. They also use the IEC symbols, and I actually do prefer the American way of doing it with these symbols. Guillermo, thank you, appreciate it, buddy. Thank you very much. What's my preference? Allen Bradley, Siemens, or GE? So out of those three, I would say it is Siemens, but my overall preference would be Mitsubishi. So I use a lot of Mitsubishi PLCs. So if you needed something like this, you could buy a smart relay, write the code, upload it to the relay, and yeah, exactly that, Oscar. If you want to, like I said, I've used these, you know, on actual jobs doing fuel control, so transferring fuel between two tanks. I've used it on an agitator control panel, which was for a vegan cheese factory or something like that. Some mad setting, but basically it cleaned out the tank, let all a load of hot water in, it spun the paddle up, the agitator paddle inside the tank. There was a few safety switches and stuff, but that went through a safety relay. Yeah, they're pretty good. Yeah, Siemens has the German and US version also for coding. Do you mean the symbols? I didn't know you could change the symbols, if that's what you mean. Finally managed to build that rig up from Ash. You've started the Mitsubishi one. Nice, Kyle. Nice, mate. You'll have to get some TikToks put up. I ain't seen any for a little while. Mohammed, thank you for the follow. Appreciate that, buddy. M Cause, thank you for the follow as well. Really appreciate it. Because you're an electrician but never personally done work like this, it's so interesting to know. Yeah, Oscar, I would say if you are an electrician, you haven't really done much programming, anything really with PLCs, then a smart relay is a really, really good starting point. It doesn't take much to set it up. There's no like crazy settings you have to go through to get it running. You literally buy it, you get the software. The software is free, particularly for Zelio anyway, for the Schneider Zelios. The software is free. You can just get straight to programming. The only one thing I would say about the Zelio over the logo I kind of mentioned that a minute ago is the logo has Ethernet. So all you need to program a logo is an Ethernet cable. With the Zelio, the Schneiders, they have a proprietary lead. So you do need to buy that lead. I can't remember how much it is. It's like £100 or something. But once you've got the lead, you can program, all the, hundreds of them if you really wanted. You're in the US, you mainly AB. Do I have pictures of a Mitsubishi in-store I could share? Probably not on this computer, I would say. I probably have some TikToks. If you go way back, if you scroll way down my TikTok page, there'll be some pictures or videos or something of some of the control panels we've done. You're learning all of it in school. You're from Switzerland. It's called Automatic Engineer. Yeah, I don't speak Swiss, mate, but I know what you're saying. You're an automation engineer.
Thanks for the follow.
Yannick, thank you for the follow. Appreciate that. Mohammed, thank you for the follow. Appreciate that. So does a smart relay just fit on DIN rail or something? Yeah, exactly that, mate. That's it. I wonder if I can... I don't think there's a way of showing you what one looks like. If you look on my TikTok, I've got videos of Schneider Zelio smart relays, so you'll be able to see them. They just stick on DIN rail, yeah. They have a power supply at the top, so I usually use 24 volt DC ones. All the inputs are at the top, all the outputs are at the bottom. You can get relay outputs or transistor outputs depending on what you need. I think the relay outputs as well, pretty beefy. They go up to, they're like 8 amp rated. I don't know if I'd ever trust that 8 amp, but they're supposed to be pretty beefy relays. You're not at the time, mate. Some of the armchair experts. Yeah, I know what you mean. You kind of have to just either ignore it or block them, mute them, something like that. Yeah, people can get a bit wild on the internet. Right. So, what else can I show? So there is a cam feature. I've mentioned this before in some of the lives. This is pretty good for if you've got some sequences you need to set up. you basically can say when you're in position 1, you
Thanks
want
for the
output
follow.
1 on, 3, 5, 7. When you're in position 2, maybe you want the others. Maybe if you're in position 3, you only want the first 3 on. When you're in position 4, you want the first 4 on. You know, this is all just depending on how you want to go about things. So what I can do now is, if that's the forward, let's put a reset in. I can kind of show you how this works. It basically allows you to do a sequencer inside this to maybe turn on certain outputs or activate certain logic in certain stages, or you know, it's a step based. It's step based. So I mean, you can see down here that's the position. So I'm in position 2 at the minute, and on the next rising edge of this cam, it will go to position 3. So you can see there's 3. I think the next one I said the first 4 come on. So in position 4, yeah. And it basically just sequences through that sequence that I'd set up. And you can see down
Thanks
the bottom
for the follow.
what step we're in. So just to go back, what it's doing is in each position. So position 1, it's activating switch 1, which was that top one. It's turning off switch 2. Switch 3 is activating. And it's just basically going through like that. And you can use that in your logic to create a sequencer. And with sequencers, you might have a sequential process that on it's always the same. But each step, you know, you might want to turn an output, I don't know, solenoid A on in stage 1. In stage like step 2, you might want to turn on solenoid B, but turn off solenoid A.
Here we go. Money
Yeah,
talk.
they're pretty useful. Dima, appreciate that. Thank you for the rose. Appreciate that. Thank you. How much is one of these smart relays? They're about £150 or something like that. Depends where you get it from, I think. They'll more than likely be more than that on like RS components, but if you go to somewhere like, I don't know, BPX or someone like that, depends where you live. If you live in the UK, BPX probably have them for about 150 or something like that. Dima, this is Schneider Zelio Soft 2.
Thanks for the
It's
follow.
a software for smart relays. Daniel, I don't do BMS or air handling units. No, I do power generation. Just logical controls. Thank you. Appreciate it. Thank you very much.
Money talk.
Right. So going back, appreciate the follows as well. By the way, guys. Akbal, I think, and Razvan. Appreciate it. Thank you. It looks like fault and event trees. I'm not sure what that is, mate. I'm not sure what you're saying there. So yeah, I mean, if anyone's done anything with what were they called? CPAM relays. If anyone does any sort of power generation stuff or power distribution, CPAM HV protection relays, they used to use basically a Zelio logic inside them. So if you needed to do anything, sort of any bespoke logic in the protection relays, the software looked almost exactly like this. No, I still haven't sorted the volume up. Mate, I don't know what I'm doing with this software, that's why. I have no idea. There's just settings upon settings upon settings. However, I did sort out where if someone just sends like 10, I don't know, roses or something, it doesn't play it 10 times, because that's what used to wind me up. I can make it a bit quieter though, I think. Let's turn the volume down there. Hopefully that's a bit better.
Thanks for the follow.
Razvan, it's not Mitsubishi, no, this is Schneider software. Andreas, thank you for the follow, appreciate that.
Here we go.
I do have YouTube. Still a bit loud. We'll see if that's any quieter.
Thanks for the follow.
Yes, I do have YouTube. The link is in my bio. All these live streams that I do go up on YouTube. So if you missed any of it, if you joined halfway through, they'll be up on YouTube like the following day, and you'll be able to see the rest. Yeah, I know, Dima. I know. I noticed that. Yeah, this software that I use for like the overlays.
Here comes the money.
It's not straightforward.
Here we go. Money talk.
Here comes the money.
can do a lot with it, but it doesn't make it easy to set up stuff. Yeah, I don't know. We're gonna have to live with it, I think. I do a lot with Schneider. Yeah, I do. I use their PLCs reasonably often, and I use the smart relays. I use a lot of their switchgear. Yeah, I use a lot of Schneider stuff. I'll be honest. Yeah. Looks like GX Developer. No, it doesn't look anything like GX Developer as far as I'm aware. There's GX Works 3. I don't think I even have GX Developer on here. I have GX Works 2. Yeah, it's this function block diagram. Although that being said, I don't think I've ever used function block diagram in a Mitsubishi, so I'm not sure. Maybe it does. Mr. Electric, thank you for the follow. DTC, thank you to follow. I think I said Andreas, but anyway, thank you for the follow. Appreciate it. Yeah, that's it. So, right, back to this. What else was I going to show? So you do get some SFC functions in here. I'll be honest, I don't know SFC. I don't use it ever. But you do get those. So although, like I was showing you the cam for doing sequencing, you can use some sequential function chart and do all that sort of stuff. I don't know that language. I never really use it ever. But there are blocks in there to allow it. I can't tell you what the blocks do because I don't use it. Yeah. FB is crap. It's only good in the logo. I'm with you on that, to be honest. I don't use function block diagram all that often, but when it comes to smart relays, I definitely prefer it because it does do ladder as well. I can change this to ladder. Well, I can just start a new one. You can do ladder or function block diagram, but the ladder is very basic. There's not a great. I mean, you can do certain stuff. I prefer the. No, it's not that one, is it? It's that one. I prefer the function block diagram in it because a lot of the stuff, like there's a lot of functions in there that just save your programming time. Yeah, it does have a ladder editor. You can put some comments in and comment it up, which is pretty good. But at the end of the day, it's very basic. And I just prefer the function block diagram in the smart relays. So let's bin that off. There we go. You do have to put in your inputs if you're going to use them. A load of the inputs are analog as well, so you can. I think it's a lot of the lettered ones. That one there, I think. Yeah. So you can do some stuff with analogs as well. What can I do? Where's the comparison? There it is. So I can say if the analog input, I think the 0 to 10 volt, the analog inputs, and you get a 8-bit number, so it's 0 to 255. So I can say if that is greater than, and I can get a constant, I think, that one there. So I can say if the analog input is greater than, say, 150, then, I don't know, we run the motor. So I can make, I don't know, run a fan. So say it could be a temperature sensor, and if the temperature gets over a certain amount, we run a fan. And I could set that to 100. I think I actually can get a little dial. There we go. I've forced it. Hang on. Release. Yeah, there we go. So if we go over 150, this line should turn red. This should start spinning. And you would have to scale it. You would have to work out, you know, what is 150. That could be, I don't know, 35 degrees or something. And you can do basic stuff like that with analog. So it's pretty good. It's pretty good. Unitronic software is free. Don't bother with me software. Oh, jeez. Yeah, I've not touched the Unitronic stuff. I seen all your stresses with it earlier. I'm doing a job at the minute where I'm interfacing with one, but I'm just providing it some Modbus registers and writing to it as well. So I don't actually have to do anything with the PLC itself. Someone else is doing that. What's the name of the software? This is called Zelio Soft 2. This is a Schneider Zelio Smart Relay NS, I think. Yeah. So that's basically what I was starting with tonight. A little bit of smart relay programming, but I've got some other stuff. I have got this open. This was basically, I don't know if anyone's seen my latest video. I did a video about basically communication between PLCs. How I was using a switch on one PLC, turning it on and off, and it was turning a light on and off on another, and then doing the same vice versa. So I could show a little bit of that. And that was pretty easy to set up, to be fair. If I look at my Ethernet port. So because it was Mitsubishi to Mitsubishi, it was even easier. All I had to do was set up. In fact, this isn't the program. It was the other PLC. Hang on, let me try and bring it up. 1 second. It was done with CC Link, but it was there was a master and a slave. I'd just picked up the slave program. This should be the right one. Let me just sort this out for you. So basically, yeah, there's two PLCs talking to each other, and if I bring up the Ethernet port, because they were both Mitsubishi PLCs, it was super simple to set up. Let's have a look. Not that one. Simple PLC communications. I don't know what you can see at the moment. Not a lot, probably. So I've got two PLCs. They're both Mitsubishi IQFs. One has the IP address of 192.168.0.5, and the other one has 192.168.0.55. And the only reason I did that was because they're both FX5s. So that way I know what they are. So we've got a read function and a write function, and it happens every 100 milliseconds. So it reads a load of data every 100 milliseconds, and then it writes a load of data every 100 milliseconds. It's currently reading. Let me just go back. It's a little bit of a nightmare. Right, okay. Hang on, I've lost my bearings. There we go. So it's reading 16 bits out of that other PLC, and it's reading them from register, the B registers, from 0 to F, and it's hexadecimal, so it's reading 16. 0 to F is 16 bits, and then it's placing them in its own B register at the same address. So the other PLC, any bits that turn on in B 0 to F, it will turn on bits B 0 to F in this PLC. And I'm also reading some word registers, or 16-bit registers, and I'm reading 16 of those. And those are W registers, and I'm reading 0 to F again. So any values or anything like that are in the other PLC, say if it has a sensor to it, a temperature sensor or a level sensor or something like that, it could store them in those W registers, and they would get read into this PLC also. And again, I'm just storing them in the same place that I read them from. So this PLC and that PLC both have the same W0, they have the same W1, whatever it is. And then that's the reading part. Then I'm writing. So writing from this PLC, which is the 55 PLC, the 0.55, into the 0.5, and I'm going to be writing 16 bits and 16-bit registers. So that was writing, from this PLC's bit B10 to B1F. So again, that's 16. I'm writing to B10 and B1F. And basically that allows either PLC to put data into these
Thanks for the
registers, and it
follow.
gets pulled across between the two of them. Drago, appreciate that. Thank you, brother. Oh, I've missed some comments. Hang on. How do I connect it to the PC? Do I need an interface? What was that in regards to? Was that into with the Schneider Zelios? Yeah, you need. There's like a little cable that you plug into it. Do I generally use Schneider PLCs or do you use others? In general, I use Mitsubishi PLCs and Schneider PLCs. Yeah. Thank you for the follow. Appreciate that. You tried it with Siemens and it didn't work. A Siemens logo, is that what you're talking about? You're a EE student, you use Tier Portal, want to learn some other programs. Do I have any other PLC programs? Yeah, this is Mitsubishi. That's what I'm showing right now. GXWorks 3. Wieland, I don't speak any other language other than English, brother, I'm afraid. You're an apprentice electrician, but your work doesn't learn your PLC programming. So I appreciate that, Drago. Thank you, mate. Yeah, so that was basically all I needed to do to get that video set up. The only other thing I had to do was actually write to the outputs. So on this PLC here, by switching that switch into the left position or the right position, I was writing to B1E and B1F, which was then being written to the other PLC, and the other PLC, used B1E and B1F to drive the outputs. So that was how I got this, in that video I got the PLC over on the left, the switch went left or right, and that data was written across to the other PLC, which used it on its LED outputs. And you can see what I've done here is basically the other PLC, when it switch went left or right,
Thanks for the
activated
follow.
bit 0E or 0F, and I use that to physically drive them LEDs on the outputs of that PLC. So yeah, it's not too difficult, to be fair. Rico, thank you to follow. I appreciate that. Yeah, so that was a little bit about how I set that up, really. All this stuff up here that you can see, you can't see very well. Hang on, I'm not showing this very well. This logic in here was just there to basically for when I was testing the communication. I wanted to increase some counters and stuff so I could see it all working. In fact, no, I could go live. I think they are turned on at the minute and I am connected to them. Let me just go into monitor mode. It should work. You'll be able to see these counting up and see how these registers are written. I want device monitor up here. I'll try and zoom that in a bit for you. If I put in, excuse me, W0, you can see that W3 is currently counting from 0 to 5 and then resetting. And that was what it was doing in the logic just there. So there's 0 to 5. Yeah. And if I go back to that logic, you can see, in fact, it was happening on W13 as well. I'll just close that down. So the same thing's happening on W13. W13, so W10 to WF, 1F, is this PLC that I'm monitoring. W0 to W0F is the other PLC. So them numbers that are increasing and counting there, that's done in actually the other PLC, and we're just reading that. Whereas W13, that's what I'm doing in this PLC. And you can see there's W13 there just counting up. And in fact, in this one, it counts from 0 to 6 and then resets. Communication between two PLCs is more basic in tier, actually. Yeah, it maybe is, but it's definitely not difficult in this. I've obviously used Tier Portal a reasonable amount recently. Well, probably not for like a month, but I did all those live streams doing the factory I/O stuff, a few videos and stuff, but I've only got one Schneider PLC, so I haven't actually had a play with doing any communications or anything like What is this app name? This is GXWorks 3. This is Mitsubishi's PLC programming software. So yeah, that's this W13 that you could just see counting up there. And like I say, this one actually I think goes to 6 rather than 5. 5, 6, yeah. Whereas that one reset at 5. What else was I gonna show? Don't think. I don't know. Maybe I can. Can I go live with the HMI? So this is the HMI I used. Can't remember if I used it on the video or not, to be fair. Yeah, I'm not sure. I'm not sure how to go live with that one. I'll have to have a play with that. And what was the last thing? That was maybe it, actually. Yeah, I was just coming on tonight just to show some stuff, really. Can I do Siemens Logo Soft Comfort Live? I don't think I've got it on this computer. I definitely could, because it's very similar to Schneider. It's not a million miles different. The symbols obviously look all a bit different, but in the way that it works, so like in Schneider Zelio, you have a left rail and you have a right rail. If I pull that in, you'll be able to see. You don't really get that with Logo Soft. Like the inputs can just be put into the software, you know, any part of the sheet. So you could have inputs over here actually. That's not the way it works in Schneider. They have to be in their socket. Dima, appreciate that, thank you. But yeah, I could. I'll have to download the software on this computer though. Yeah. I'm probably going to call it a night there, I think, guys. We're coming up to an hour online now, so it was a bit of a short one tonight. It's been a while since I went live, maybe like, it's probably about a month exactly, actually. But yeah, Christmas was busy, work was busy, so I think I might have, did I do a live a couple of weeks ago? Maybe I did, I can't remember. But I'm going to ease myself back into it. We're going to be going live again more often again, but yeah, it was a nice soft one into the lives again. I appreciate everyone who showed up. Thank you everyone who's liked. Thank you to everyone who's gifted. I had a few gifts. I had a lot of follows tonight. Thank you very much. The next live, I might do one tomorrow. Yeah, we'll see. If not tomorrow, then next Friday. I tend to stick to the weekends, Dima. Yeah, I'm going to try and aim for tomorrow. So maybe around the same time, 7:30, 8 p.m.-ish UK time. And maybe I can try and get Logo Soft before then. We'll see. We'll see what we come up with. Appreciate all those gifts as well, Dean. I really appreciate them. So I'm going to get off, and I will see you the next time we're live. Appreciate it.